Hey everyone, welcome back for another deep dive. Today we're going underground, well, not literally,
Right.
but we're going to dig deep into a hidden danger that could be lurking right beneath your feet. We're talking about sub-slab remediation for a contaminant called trichloroethylene.
TCE.
Yeah, exactly, TCE. And to help us navigate this invisible threat, I've got expert name with me, expert title at Expert Company. Welcome to the show.
Thanks for having me.
So before we get into the nitty-gritty of remediation, let's paint a picture for our listeners. Imagine this. You've just snagged your dream home. Everything seems perfect. But what you don't know is that there's a hidden danger, this TCE, potentially lurking beneath those beautiful hardwood floors.
It's a silent threat, and it's more common than people think.
Okay, so set the stage for us. What exactly is TCE, and why should we be concerned about it if we can't even see it?
So TCE, or trichloroethylene as it's formally known, it's a colorless liquid. You can't really smell it at low levels, but it can be, well, it's definitely hazardous to human health.
Okay, hazardous how? What kind of risks are we talking about here?
Primarily with prolonged exposure, it can affect the central nervous system, the liver, and some studies even link it to an increased risk of certain cancers.
So definitely not something you want hanging around your basement then.
Exactly. And what makes it even trickier is that it can be present in the soil and groundwater beneath buildings, and it can seep up through cracks and gaps in the foundation. That's where the whole sub-slab part comes in.
So it's getting into the air we breathe in our homes.
Exactly. And you can't just air out the house to get rid of it.
Right, that wouldn't do much good in this case. And I understand there are actually different standards for acceptable levels of TCE.
Absolutely. So you've got the EPA, the Environmental Protection Agency, setting guidelines at the national level. But then some states, like Massachusetts, where we are, they've decided to take a more stringent approach.
They're playing it extra safe.
They are. They've got the MassDP, the Massachusetts Department of Environmental Protection, and they set their own stricter limits for TCE in indoor air.
And that's because...
Well, every situation is unique, but broadly speaking, Massachusetts has a history of being proactive when it comes to environmental protection. They're often on the forefront of setting stricter standards, especially when you consider things like protecting vulnerable populations like pregnant women and children.
Makes sense. So let's say we've done some testing and discovered that, oh no, we've got a TCE problem under our house. What happens next? What can be done about it?
That's where sub-slab remediation comes in.
Okay, so we're finally digging into the main course here. Tell me everything.
Well, there are two primary methods that are used: sub-slab depressurization, SSD, and soil vapor extraction, or SVE.
Two different acronyms, two different approaches. Let's break them down, shall we? Let's start with SSD. How does that work?
So SSD, imagine it like this. You're essentially creating a vacuum under your house.
Okay.
Not literally a vacuum, but you're lowering the air pressure beneath the building relative to the air pressure inside.
Okay, so it's like we're putting a force field against the TCE, preventing it from entering the house.
Exactly. You're creating this barrier that stops that vapor from seeping up into your living space. It's all about negative pressure.
Interesting. So it's not actually removing the TCE from the soil. It's more like controlling it, keeping it at bay.
Precisely. Think of it like, those screens people put on their windows to keep bugs out.
Sure.
It's like that, but for invisible, potentially harmful vapor.
I like it. And these SSD systems, are they complicated to install? Do they have to dig super deep under the house?
Actually, not as deep as you might think. The extraction points for SSD are usually installed just a few feet below the building.
Oh, really? Just a few feet?
Yeah, right around where that vapor is most likely to try and sneak in.
Fascinating. Okay, so that's SSD, our negative pressure shield. Now, what about SVE? This one sounds a little more intense, judging by the name.
You could say that. If SSD is about containment, SVE is about removal. We're talking active extraction here.
So going on the offensive.
Exactly.
Yeah.
SVE systems, they directly target and remove the contaminated soil gas, and they go deeper than SSD, typically more than 5 feet below ground.
Wow, so this is really getting down into the thick of it.
It is. And because it's more about active removal, SVE systems generally operate at much higher flow rates than SSD. We're talking much larger volumes of air being pulled out of the ground.
So SVE is like the heavy-duty vacuum cleaner of the remediation world.
That's a great way to put it. And because of that, SVE is often more effective for larger contamination plumes, or if the contamination extends beyond the immediate area of your house.
So it sounds like choosing between SSD and SDE isn't as simple as picking one over the other.
Yeah.
There are a lot of factors at play.
You got it. It's not about which one is inherently better. It's about choosing the best tool for the job, and a major factor in that decision: soil permeability.
Permeability. It all comes down to dirt.
In a way, it does. Remember, permeability refers to how easily things, like liquids or gases, can move through the soil. Imagine pouring water on tightly packed clay versus loose, sandy soil.
Okay, I can picture that.
The sandy soil is much more permeable, so the water drains through quickly. Clay, though, not so much. And the same principle applies to vapor movement in the soil. That's going to significantly influence how effective these remediation systems can be.
So if I'm picturing this right, in highly permeable soil, you could potentially pull out a lot of that contaminated vapor with SVE, even if the vacuum pressure isn't super strong, right?
Exactly, because that vapor can move more freely through the soil. But in denser, less permeable soils, even a strong vacuum might struggle to pull much of anything out. It's like trying to suck a thick milkshake through a tiny straw. You need that flow, that permeability, to make it work well.
That makes a lot of sense. So it's not just about the TCE itself, it's about the environment it's in, the soil conditions, that kind of thing.
Exactly. It's like putting together a puzzle. You need all the pieces to see the full picture.
So we've got SSD, our negative pressure shield, great for containment, especially in those trickier, less permeable soils. Then we've got SVE, our heavy-duty extractor, really effective in permeable soil and for larger scale contamination.
You got it.
But when it comes to choosing, it sounds like factors like, I don't know, the severity of the contamination, the soil conditions, even the cost of these different systems, they all come into play.
They absolutely do. And there's one more layer to consider, too.
Well, what's that?
The environmental impact. Even though we're talking about cleaning up a contaminant, these remediation systems themselves, they use energy to run. And some systems, like SVE, because they often run at higher flow rates, they can be more energy intensive.
Right. So even when we're trying to solve an environmental problem, there are still trade-offs to consider.
There are. It's about finding that balance between effectiveness, cost, and long-term impact.
It's a lot to think about, but I think the biggest takeaway here is awareness.
I agree.
You might not be able to see TCE, you might not even know it's there, but arming yourself with knowledge, that's the first step towards making informed decisions about your health in your home.
Absolutely. Knowledge is power, especially in this case.
Couldn't agree more. This has been incredibly insightful. Thank you so much for taking us on this deep dive into the world of sub-slab remediation.
Happy to be here.
And for our listeners, thanks for joining us on this journey underground. Until next time, stay curious and keep diving deep.